Great to see so many of you here. Welcome to ACOps, the missing link. We'll get started by talking a little bit about Azure and how the way we build and manage Azure has evolved during the last few years. So when an organization starts to use Azure, it's very common that someone starts by setting up a subscription. It might be a development team, it might be a part of the organization, it might be a part of the IT, but someone in the organization needs some Azure. They make sure to buy some Azure and they set up a subscription. That went well, and a little bit later, some other part of our organization buys some Azure. So we'll have another subscription, and later on, they realized that they need to talk to a server on premises. So they set up some kind of hybrid connection, a VPN or something, and our environment grows organically like this. So suddenly we have two subscriptions that connects to on-prem in some way, and then we have this another subscription, and it grows and it grows and it grows. And in the end, we have an environment that looks somewhat like this. I used to call this an Azure archipelago. It's a set of islands of Azure. And this is hard to manage. It's hard to have a good governance of. It's hard to know which thing costs how much and how should we project it, who owns what. So Microsoft has a great solution to this problem. It used to be called Project North Star, and then it was called Enterprise Scale Architecture, and now it's called Azure Landing Zones. So, and the problem with this is that there is a lot of not only cost but also security risks. I snipped some headlines from different newspapers and reports saying that basically the amount of security incidents are growing exponentially, and a lot of them are due to misconfigurations in cloud. And we'll also, this last picture, the 70% here, says it's a report from Snyk, the security company, from last autumn, I think. And they have realized, or their report says that if you go from using manually clicking in the Azure portal to actually deploying your infrastructure using infrastructure as code. In this example, we're going to use Azure ARM templates and Bicep. You can reduce the number of misconfigurations in your environment by a median of 70%, which is a lot. So, two things. We're going to build a better structured environment, and we're going to use infrastructure as code. Back in the days, our IT infrastructure looked somewhat like this. We had a great wall around our IT environment. We had a perimeter protection. We had a big firewall. And as long as you were inside the firewall, you were pretty much trusted. Just like this medieval town, there is a small gate in the wall. If you can pass through that gate, if the guards let you in, you pretty much have access to all the houses within the city. There are no good locks. Then we started building Azure environments, and our application suddenly looks somewhat like that. Now our development team, our application teams, pretty much anyone in our organization could technically build their own floating island and put their little house on it. And we have no idea who approaches in an air balloon or whatever kind of travel they use to access our system that I try to show with this island. So we need to protect this island, and not just this island. We might have hundreds and even thousands of islands. So we need to make sure that all our islands are self-sufficient. We need to make sure that all our islands are protected with their own protections. And that is also a good reason to build a good structure and a good organization. We have a bunch of tools available in Azure to make sure that this protection is in place. Because nowadays, when developers and application teams and parts of our organization start building their own infrastructure, they often get to administer and run it themselves. So we need to have central controls that make sure that we are compliant, that we have the right protections, the right security mechanisms all over our organization and all over our environment. My name is Simon Wåhlin. I work as a cloud consultant on a company called Advania in Sweden. I mainly do coding and development stuff on my spare time by night, and by day I'm an Azure architect working with customers mostly in Sweden. I want to thank all our sponsors. Like you heard so many times, without them we hadn't been here today. And please visit them in the open area and talk to them at their booths. So, to start to solve this problem with central governance and a good organization, we need to build a structure where we can inherit policies. We want to apply our policies high up in our organization so it gets inherited everywhere, and we want to apply our access assignments as far down in our organization as possible so we have least privilege. To do this, Microsoft has built an excellent example of reference infrastructure called Azure Landing Zones, and it basically works like this. First, you need an identity catalog, in this case Azure AD, and you need a tenant and you need the ability to buy Azure. Once you have that, you set up a bunch of management groups. Management groups are just metadata containers in Azure where we can structure our subscriptions into some kind of structure. So in this case, I'm going to set up a management group called Contoso, Platform, Landing Zones, and Sandbox. So here we have our customer root. In this case, we call it our fictional company name Contoso. Under that root, we're going to create a platform management group that will hold all our central IT infrastructure. And then we're going to put up a landing zones management group that will hold all our application infrastructure, all our systems basically. And then we have a sandbox environment where we can put all our proof of concepts, all our testing, all our experimenting, all our innovation stuff. Because mostly the rules we will need to govern our platform, our central platform resources, they're usually managed by a very small team. So we might not need as granular rules for that, but our landing zones could potentially be managed and owned by different parts of our organization and by teams all over our organization. So there we probably need a lot more rules and governance. And on the sandbox part, we again need a lot less rules and governance, because that's where we want to be able to do testing and experimenting and all that stuff. So under the platform, the recommendation is to create a management connectivity and identity management group. We use this to be able to delegate to different parts of our IT organization. So in management, we usually put anything that is used to automate or manage this platform. In connectivity, we usually put anything network related. And in identity, we put identity related stuff like domain controllers and maybe HSMs and stuff. This isn't by any means a law or this is the only way to do it. This is just one way to do it. And if your organization is separated in some other way, feel free to use your own sub-management groups under the platform part. So we put subscriptions. We can have one or more subscriptions in each of these, of course. And then landing zone. We often split landing zone in corp and online. Some of our customers choose to call it private and public. Some of them call it internal and external. You can pretty much call it whatever you want. But in the CloudOcean framework, we call these archetypes. And the point here is that corp should contain all our systems that traditionally would be connected to our internal network, that traditionally would be inside of the Great City Wall. So we usually have policies here saying that if you want to deploy anything here, you can absolutely have virtual network connections into our central firewall. You can talk to our on-premises systems, and you can talk to like all our other internal systems, but you're not allowed to have like public IPs, you're not allowed to have public endpoints and so on, to reduce the risk that we have a system that has one leg on the internet with a public endpoint and one leg on our internal network, and by that creating a bridge between our like protected perimeter network and our external network. And in the online archetype, we do basically the opposite. Here we put all the systems that do not need any network connection directly to our internal networks. Here we put like external web services, basically anything that needs to be accessible directly from the internet, or things that do not need to connect to through the stuff in Corp. So in online we can have public endpoints, we can have public IPs, but we cannot have connections to virtual networks, or at least not the central internal virtual network. So we can put subscriptions in those, and we also have the sandbox part. So this is like the core concept of Azure landing zones. It is greatly described in the cloud adoption framework, and there is a link like aka.ms/ALZ for Azure landing zones. So there's a lot of example code and stuff. Then we need to manage all this as code. So that means two problems. First off, if we haven't created everything as code from beginning, how can we take the configuration we have in Azure and create code that we can start managing? How can we like turn around the way we manage this if we don't want to manage it using clicking in the portal kind of processes? Well, that's where we have a tool called ACOps. So ACOps basically does two things for us. It can export theoretically any resource from Azure into a Git repository, and it lets us commit a ARM template or Bicep file to that Git repository, and ACOps will figure out where to deploy it. So why should we use infrastructure as code? This is a picture or a few screenshots of the Azure portal through time. And what I want to represent here is that the Azure portal changes. And even though it doesn't change this drastically very often, there is a lot of changes. So if I have an instruction saying to deploy this resource, you need to go here, click there, type this, do that, do this, click here, click deploy. We cannot really be certain that that instruction will work tomorrow, next week, next month, or next year. And even if that instruction works next year, it might not result in the same infrastructure as it did today. Because what the Azure portal does under the hood might change. So we want to use infrastructure as code. I like to use Bicep, and the cool thing about using Bicep or ARM templates is that I can here supply a storage account, say I'm going to create a storage account, and then I give it an API version. So the @ and the thing that looks a date, like a date there is actually an API version. And if I deploy this template using that API version, I should be able to get the exact same result every time. Today, tomorrow, next year, and maybe in 5 or 10 years from now, assuming the ARM API is still up and running. And we can still use the API versions all back to 2015, and they still work, and they still produce almost the exact same result as they did in 2015. There are obviously a few features that has been added. Those features aren't exposed in the 2015 version of the APIs. So a lot of those features will get default values if I use an old API version. But for most part, I will get exactly the same resource if I deploy it in 2015, 2018, or 2023. Also, when we do, I thought there was supposed to be an animation there, sorry. So when we do a change, if we are using the Azure portal, I have to sign into the portal. I have to click around until I find the thing I want to change, and then I change it. And when I change it, or when I click save, that's when it's going to happen. What if I make a mistake? I'm only human. I mistype things all the time. I misunderstand what we want to do. I misunderstand requirements, and I might misconfigure something. Not intentionally, but like I thought this was what you wanted to have. If we use ACOps or any other tool that doesn't let me connect to the Azure portal and do the actual change in production, then I can use the traditional Git process to make a change. So if I have all my infrastructure in a Git repository, I can, as the developer up there, make a change to a file. I can open a pull request. And when the pull request is opened, ACOps has a pipeline that will automatically do a what-if deployment. And that pipeline will then post the what-if deployment result as a comment to our pull request. And then my colleague, the approver here, can look at that comment and get a good insight in what is going to change if I approve this change, what is going to happen. It's obviously not perfect because what if isn't really perfect, but it gives a good indication on what will change when we deploy this. And then they can approve the pull request, merge it to main, and then our deployment pipeline will perform that change. This will drastically reduce the amount of human errors, the amount of mistakes, just because we make sure that we always have at least 2 people looking at a change before we actually perform a change. This also makes it a lot easier to make sure that we do the same change in our dev environment, test environment, and production environment. But how should we do it? Well, let me introduce ACOps. So ACOps is a project by Microsoft. And it's hosted on GitHub. It consists of 2 things. It's a PowerShell module, and it's a set of pipelines. It has pipelines for GitHub and for Azure DevOps, and today we're going to look at the GitHub pipelines or actions. So what will happen in my demo that I will run soon, hopefully, I have an environment in Azure. So I have a bunch of resource groups, I have a bunch of subscriptions, and I have some management groups. So I have an Azure environment. I'm going to run a pull pipeline. That's the upper one that says pull. That will iterate all my resources in Azure, and it will export ARM templates for every resource that I choose to include in my settings. Once that's done, ACOps will create a folder structure for me. So as you can see here, see if I can get some laser pointer. Maybe not. As we can see here, the folder structure on our left is representing the management group and subscription structure on our right. So our Contoso management group on the top is our Contoso folder. Under the Contoso folder, we have a platform, landing zone, and sandbox, and that's our platform, landing zone, and sandbox folders. And within the landing zone folder, we have a customer one folder, which is a subscription, and then we have the app RG folder, which is a resource group. Since in the file structure we only have folders and files, it's a bit harder to keep track of what's a subscription and what's a resource group, but once you get used to like your structure, it's fairly easy to find your way. So what I can do here, if I want to deploy something, I can take this storage.json, which is an ARM template, or the keyvault.bicep, which is a bicep template. Commit that to the repository, and that will trigger a push pipeline, and the push pipeline will deploy this to my test RG resource group, which since it's located in the test RG folder. So ACOps basically maps Azure structure to folder structure. And whenever we put a file in the file structure, it will deploy that to the corresponding Azure structure. So let's look at how this works. To start, we go to github.com/azure/ACOps. This is the repository for the PowerShell module, and it's also the repository that has all the instructions we need. If we go down to the README here, it says that there is an ACOps accelerator we can use. If we click on that, we'll go to the ACOps accelerator repository, and this is a template repository. So I can, in GitHub, click use this template, and it will create a repository identical to this repository, but in my organization. I can also clone this and push it to a Azure DevOps repository, and whether I choose to use GitHub or Azure DevOps, there are pipelines or actions defined for both scenarios. If we go back to ACOps, there is a wiki, so we can go into the wiki part here, and this has a lot of documentation about how this works. To get started, we need to go into the prerequisites. If you're on Windows, there is a troubleshooting document down here, right? And since this is going to generate very long file names, you'll have to enable long file names on Windows. It's a registry key and a Git setting. Just make sure to run those before you try to set this up, and you'll be fine. So next part, we need some prerequisites. I have sheeted and created these already. But basically, we need a service principal and some access. So our pipeline will need to have access to our management group structure, obviously, because otherwise it can't read or write to it. I usually assign it owner permissions because I usually use this to deploy RBAC permissions, role definitions, and policies. And if I want to apply both of those, I usually need owner permissions. So I have started and created a service principal in my Azure AD. I have given it access to a management group. And I can show you we can do that while we're waiting. Next part is to choose GitHub Actions or Azure Pipelines. So if I want to do GitHub Actions, I choose that. If I want to do pipelines, I choose that. So here is the GitHub Actions instruction. And if we scroll down here, there is a long instruction on how you click everything. And in the bottom, there is a short instruction on how you run GitHub CLI to do this. And since we are on a PowerShell conference, of course, we run GitHub CLI. So I'm going to start by doing repo name and set a variable that I'm going to call my repository. And then I'm going to use the GitHub CLI to write this command. This will create a new repository using the ACOps accelerator as a template. And then we are going to set some secrets. So I have a bunch of environment variable I have pre-created. So I'm going to do a tenant ID, a subscription ID, an ARM client ID, and an ARM client secret. I'm taking the environment variables and I'm putting them into my repository as action secrets or whatever they're called, so my workflow can access them. If I'm running my workflow or if I'm running ACOps from a private runner or a private agent in Azure DevOps, and that agent has a managed identity, I can use that instead, and then I can just skip the client ID and client secret part. Next up, we are going to do some GitHub API calls, and we are going to change the way we merge. So now we basically force every pull request to be squash merged, and that is because the whole logic behind ACOps is that when we merge to main, it will look at the diff in the last commit. So we need to have one commit, and that is what we're going to deploy. After that, we use some REST API call again, and we set some permissions to our workflow. So these permissions are permissions for our pipeline to write to our Git repository, and it's permissions for our pipeline to approve pull requests. Because when we do a pull pipeline, when we export configuration from Azure, ACOps will download all the configuration and create a new branch called automated state, and it will open a pull request with those changes. So when something is changed in Azure, ACOps will, on a schedule, export everything and create a pull request to our repository. And if we want to, auto-approve that pull request. So then it needs access to approvals. So now we have a repository. We're going to clone it. The internet is holding up. Perfect. So we are going to cd into it, and I'm going to remove some items. So in this repository, we can see that we have, well, can't see it now, but we have some code of conduct, license, readme, security, support, markdown files. These are just files relevant for the GitHub repository. It's not relevant for my repository. It's just information about how would you go ahead and contribute to this public template repository. So I'm removing that. I'm also removing the pipelines folder because that contains pipeline from Azure DevOps, and we're running GitHub today. So there should be a comma there, I think. There. Yeah, I removed that, and then let's try to commit that. So we're adding all the folders. We do a commit message, and we do a git push. There we go. And then we are going to use the GitHub API to create or dispatch an event called Enterprise Scale Deployment. So this will basically kick off our pipelines, hopefully. So we ran that, and with some luck, our pipelines are running. So if we go into my repositories in GitHub, there is a new repository called PSConfEU. And we have a new commit 3 minutes ago. It's the cleanup, and apparently I committed as manual. If we go into actions here, we'll see that we have an enterprise scale deployment running. That enterprise scale deployment is running a pull pipeline. So this is now iterating through my Azure environment. And speaking of Azure environment, let's go to the Azure portal. So this is the Azure portal, and these are the, zoom a bit, these are the management groups that are relevant for what I'm showing right now. So I have a, there we go. I have a management group called ESLC, representing enterprise scale landing zones. This is the corresponds to the Contoso management group in my slides. Under there, I have some management group called like Commission Landing Zone Platform and Sandbox, just like in the slides. And under Landing Zones and Platform, we have the Management, Identity, Connectivity, Online, and Corp management groups. On these management groups, there are a bunch of RBAC assignments, there are some policies and all that. So currently, the pipeline is working. It's going through all these and all the resources in it, and it's exporting it to ARM templates. If we go into our repository, we can see there is a settings file. So here is a settings.json file, which contains all the settings for our pipelines. The important part here is any setting that says skip. So basically, these are the ones you want to look at. So if we have a core.skip PIM, that means, if that is true, it means we are not going to export any PIM role assignments. PIM is privileged identity management, so if I have to enable Azure roles. Core skip lock, if we set that to true, we're going to skip locks, so we're not going to export any locks. So if we can see here, we are skipping PIM. We are not getting any PIM assignments. We are not getting any resources. And we are not getting any child resources. We are also excluding any resource of type listed here. So why I'm doing this is I want to export my structure. I want to export all my folders and get my folder structure. But I don't want to export my resources because I don't want anyone to have access to create resources in the portal. I want to commit a Bicep file to my repository and deploy that to Azure. If I do that, I will have like a source of truth in Git. If I export all my resources, problem is that the resources will be exported as an ARM template with a generic name, but I created it with a Bicep template with a name that makes sense to me. So if we both push and pull the same resource, we will end up with two files containing the same configuration. And that's confusing because then I don't know if I should do a change in the Bicep file or in the ARM template or what to do stuff. There is a setting that allows us to do like all, if I want to export all the resources, it also takes a bit more time to do that. There is a setting saying auto-generated folder path. So this is a dot or a period or what you call it. If we do this, all the auto-generated ARM template will end up in the actual folder corresponding the scope. If I want to, I can give it a name here saying like auto-generated or do not touch or whatever. And then ACOps will create a folder with this name in every scope. So I will have my resource group folder and I will have my do not touch subfolder or my automated subfolder. All my templates go into the actual folder and all the automated templates go into the subfolder. If I use that, I can easily look at the different, like the exported templates and my deployed templates. So hopefully by now, actions, we are done. So we can see our pull pipeline went through, it did a bunch of stuff, and it created a pull request. So if you go into the pull request, we can see we have one closed pull request by GitHub Actions, and it's called automated state. And it just had a dot as a description, and it committed 430 files. So 430 files are all my Azure resources. This is probably going to be a bit hard to see. Maybe we can see it here instead. But what you see is we have a new root folder. This root folder is the folder where all my infrastructure will be put. If I go into this root folder, you'll see that I have a folder structure that corresponds to my management group structure in Azure. So now if I want to commit something, I can go into my enterprise scale landing zone and my demo resource group. Here is an empty resource group. I can I can download all the changes, so the 430 files. I can download them to my computer locally. I can check out the new branch, and I can copy a storage Bicep into this path. So let me just super type this. There we go. So what happened here is I have this Bicep file in my folder, in my demo folder here. I'm just going to copy that into the demo RG resource group. I'm going to create a commit, and I'm going to push that to GitHub. Awesome. And if we go here, we should see that there is a new commit created. I can create a pull request, and I can say add demo storage, create a pull request. What will happen here is that this should trigger the validate pipeline. So we have a GitHub action here that is called validate. It will do a deploy with the what if flag, and it will run for a while. I have a repo I did just the other day that can save some time. So here I have a closed pull request that is the exact same. And what you can see is that our GitHub Actions workflow did a what if deploy on this storage bicep, and this is the output of the what if deploy. So this tells us I will create a new storage account with these settings in this resource group. And if we go back to the Azure portal and we go into that subscription, you'll see that we have a bunch of resource groups. We have the demo resource group, and here is the storage account that I deployed a few days ago. And if we go back here into demo 2, we will hopefully soon see that it deploys a storage account. And here is our newly created storage account any second now. Hopefully. Let's see if the push action is running. Yeah. So here is the action running. Oh, sorry, it's the validate. We haven't merged it yet. So here's our pull request, and here you can see the comment, what we're going to deploy. This time we're deploying it to the demo 2 RG. The storage account name is a little bit different, and I can squash and merge this, confirm it, and once it's merged, it will be deployed to Azure. In normal cases, I wouldn't create this pull request, review it myself, squash it, and merge it. In normal cases, I would have at least one colleague that would look at this and approve it and merge it for me. And once they approve it and merge it, it will be deployed to Azure. So now when I merge it, you see that we have a new pipeline running, which first time it ran against the demo 2 branch, which was my pull request, and now it's running against the main. And last time it did a validate, and now it's doing a push. So now it's actually doing the deployment, and in a little while we'll hopefully have a new storage account. So that in a gist is what ACOps is doing and what we can use ACOps for. While it's running, does anyone have any questions? Yes? What does it do with empty resource group? That is a good question, because Git doesn't support empty folders. So let me open a folder, and whenever we create a resource group, it will in that resource group create a template that deploys that resource group. And that's how we solve the Git doesn't support empty folders. Yes? So the question is, how would I extend this if I have PS rule or other logic I want to run within my deployment workflow? So the pipelines here are fairly composite. If we go into the accelerator here and look at the GitHub part and workflows, we have a, if we take the push here, it uses, here. So it uses composite actions, so you can easily add your own composite action and just put it in there. The only problem is when there are updates on the template repository, you can't automatically just say merge in template. You need to manually pull down the template, pull down your, and do the actual merge job. If you know what your changes are, that's a 5-minute job, so it's not a problem. But we do that at a lot of customers. We put custom logics in our pipelines, which means that we cannot automatically update the pipeline definitions from the template. We have to do it manually, but it's not very hard. Great. Any more questions? Yes?
Are Bicep parameter files supported, or does all the release archive
That's a hard question. So the question is, are Bicep parameter files supported? We are currently relying on Azure PowerShell resource deployment command, and that doesn't support Bicep parameters yet. I think there is an open pull request that should be merged any day. So no, we don't support parameter files today. We probably do it next week. Yes? So the PowerShell command new AC resource group deployment support ARM parameter files, but it doesn't support Bicep param files. Yeah, and the Bicep param files were released in version 0.18, which was released last week. Yeah, so it's very new, but it's getting there. More questions? Perfect. Then hopefully we have a deployment completed. We didn't. Sad. Oh well. You just have to trust me that it will complete and deploy. Yes. New question. Yes.
But looking at upside is loss, you need to be a contributor, so you need to trust the users. Can you get around that?
So the question is to do certain things or tasks in the Azure portal, you need to be a contributor. Is there a way to get around that? Yes and no, and not really, and it depends. So we are mainly using this to deploy our core infrastructure, to deploy our policies and our RBAC assignments and our shared infrastructure, all the critical parts where if we do something wrong, the whole organization will suffer. We are not as strict in using this or as in not assigning permissions down to specific subscriptions or specific resource groups. So no, there are no perfect solution where I can give you contributor access but not let you do contributor things. But in many cases, I can solve it either by using custom RBAC roles, or I can do a combination of you have this access, but I use policy to deny you to do stuff that you're not supposed to do, and combining that with this delegated access in as small scope as possible, I can minimize the potential damage that could be done by a mistake. Great question. Now the pipeline is complete. And if we go back to the Azure portal and refresh, we should have a new storage account. So it's fairly simple. It takes 10 minutes to set up. There is a bit more configuration if you want to get down into the weeds. You should probably put some branch rules that says you're not allowed to push to main, you're not allowed to approve your own pull requests, you need at least 1 or 2 reviewers or whatever suits your organization. But it's really easy to get started. There isn't a lot of hassle, there isn't a lot of configuration, and most of the time it just works. So I really recommend looking at ACOps, especially for larger, like doing the central governance part. Yes, question? Is it possible to remove resources? No, ACOps do not support removing resources for logical reasons, because ACOps have no idea. Like if you have a template that contains 3 resources and you remove that resource, ACOps can't really know what it should remove, so it's too risky. However, ACOps can remove auto-generated templates. So if I have here Here I have a bunch of policy assignments. So all these files are policy assignments. And since this file name is Microsoft.authorization _ policy assignments - deny data b dash pip.json, ACOps has generated this file, and ACOps knows what it will deploy. If I remove that file, ACOps can remove the corresponding resource, but it cannot remove the resources that are deployed by my custom templates. Yes, if they are exported in this format. We have solved it in a few cases with a delete pipeline where we basically commit the list of resource ID that we want deleted. And then we have a pipeline that actually just goes through that after it's approved and deletes it for us. That way I don't need to elevate my permissions and do a manual delete. So you can solve it, but it's not like a perfect scenario. There is a session on deployment stacks, right? It was yesterday, yeah, exactly, same. That might be able to help in that. Yes?
In larger organizations, there are sometimes a segmentation on what level within the research management groups certain teams may manage the infrastructure.
Absolutely.
You may have referenced it, but I may have missed it. Is there a way to pick up the level downwards? So if you start to put a management group beneath the tenant group, because we don't want to give the starting cloud engineer tenant group.
Yes, absolutely. So if you look at my root group here, you can see that I have a bunch of root management groups. I delegated access to ACOps to this ESLC management group. You can delegate it to any scope you want, and it will just see that scope and work in that scope. We have integration teams that build an integration platform and deploy an ACOps just for their 3 integration platform subscriptions. So you can do it in any scope. Awesome. And by that, thank you very much.